Swayam Prabha. Digital India. Educated India.
Welcome to our discussions. You have how things are going on. I hope you have started studying this bulk material handling and transportation. By the way, tell me whether have you been to Rajgir or Nalanda? Then, or if some of you have gone to Kolkata Science City, you might have travelled on some ropeways, aerial ropeway. That is another thing I talked. I think sometimes I told you about this aerial ropeways, but thing is that you have travelled those rope haulage system, that is which is there at Nalanda or Rajgir, or which is also there at Science City and many places. Now, I tell you a story that in Europe there are many this hills where during the winter season they go for this skiing, that they are in the snowy mountain. So, there are on many hills good hotels are there. Now, there all the people from the foothill, they are carried by a system of ropeways, on which there will be some very small cab type of container type of cars are there. Those are manufactured by a company, Doppelmayr. That Doppelmayr. So, today I am going to tell about that rope haulage. You just think of the ropeways which you are having at Nalanda. There, instead of those carrier which on which you are sitting, or that container on which the people, a group of 7, 8, 10 people are travelling, instead of those, on that rope if you keep your conveyor belt, that means high above the ground. So, this is on a trestles that your conveyor belt is going and you are carrying the coal or your bulk material over there. So, this particular system that was visualized, and today in our discussion you will be finding this transportation machinery for surface mines, where this a system RopeCon. This RopeCon is the word used by this Doppelmayr company when they combined this system of a different type of hybrid type of transportation system, which is called RopeCon Transportations. So, today after going this class, you should be able to discuss the technical features, advantages and disadvantages, and the applicability of this new bulk material transportation system, which is there now. I think it is more than 10-15 years. I think the first I talked about this RopeCon Transportations in 2008, I think in one of the mining conferences at Dhanbad. I first told about this conveyor system, which is I could get that opportunity to see at Sinberry Island in Pacific Ocean. There is an island called Sinberry, where the gold mines, gold ore is being transported to the port for taking it to Australia from the mine, about 600 or about 6 kilometer, I suppose. I forget the exact figure now, but that a long distance conveying was done by this system, which is a RopeCon. In those days in 2008, there are hardly about 6 installations in the world, but today there are many installations and they are coming up from Guatemala to South Africa to many places. So, this has not come yet to India, but I hope that some of you, if you can develop R&D and research in this area, this could be a technology of future, because of it has got number of advantages. So, you should be able to describe the components and the construction of this RopeCon, so that you can start studying and taking up some interest in this current developments, and you may be, who knows, you may be coming up with a new dream, new technology. So, this RopeCon, as you can see in the figure, that is exactly, this is a on a just like a aerial ropeway, on the rope that you can see that wheels they are moving, but this whole conveyor belt is on the wheels. That is exactly this wheel which you are seeing here as a plastic wheel, that is their axle is there all along the conveyor belt. Across the conveyor belt this axle is there, and they are supported on this wear rope, and then you can see both the carrying side and the that your return side of the belt both have got a side wall, and the whole thing is moving. And you can see from here that at the end there is one support, the other support may be at a distance of 1.5 kilometer, 2 kilometer. So, such a system could be it is really a matter of interest. Let us see how we study about it. You can see that here, as I was telling, this is a conveyor system that Doppelmayr company of Austria, this is an Austrian company, they have that combined this belt conveyor and rope, this ropeways, these two things they have combined, and then already that your, can you see that this your corrugated type of this sidewall for high angle conveying, already this was there in use from about 80s. There was one British company called Hoorise. Hoorise used to give this type of conveyor belt with a clit in between, so that they can take it in a high angle conveying systems. So, they have studied all the different systems and developed this hybrid system. So, it is it integrates both the advantages of your rope haulage as well as that of conveyor belt, and then they technically manage the problems, and it comes out to be a very good economic choice. Now, the conveyor belt fulfills both the tensile and the carrying functions, because we will have to have a tractive element here will be the rope on which this is that is your that rope is not moving, the belt is moving, that belt is given drive just like your at the end drums, but because of these wheels that belt is not supported on rollers. So, the frictions of the belt and the idlers, that is not coming. However, that only with the very specially designed plastic wheels, which will be, that is your polymer, that is your synthetic that your polymer wheels, which will be moving over the rope, giving a very less frictions. You can easily tell now about the rope that will be your lock coil rope, where there will be less frictions. So, this is a system in which the trajectory of the belt is oriented from the head pulley to the tail pulley. From one end it is loaded and the other end it is transported. So, one thing here, that in between side discharging and all that thing, if you want to transport the material at different places, there will be difficulty. There are certain difficulties that if you are if you want a flexibility in the loading and all that thing, but many places here we do not require a flexible unloading system. You can think of when we are going to deep surface mines in India for our future coal and mineral demand. From there, already you may be knowing that our Indian Railway and then Coal India Limited, they are having their joint collaborations with having a rapid loading system with silo, which is coming in our that is your wherever there is a that our that railway siding on which the railway wagons are being loaded. Now, in that silo you can bring from the pit, even from underground mines, this transportation system can start their loading at the underground mine. From there it can come up to the surface, and from there go to the railway where that your silos are there. You will be loading onto the silo, and from the silo when the wagons will be coming rapidly loading and then going to the your metallurgical plant or to the thermal power station. So, that type of the very advanced and technologically sound, environmentally friendly system can be introduced with this particular system. So, I hope some of you will be getting interest in studying this. So, it is clear that what is this, then you have seen in the previous figure, a conveyor belt with a sidewall is there and moving on wheels on the conveyor. So, there are some of the components that you will find in this system is the track rope. That rope which is there, it is called your track rope. Just like your railway, you have got the track on the trestle, it is at a higher elevations, you are maintaining this rope as a track on which that exactly now these tracks is kept at that higher elevation by supporting frame. This supporting frame, you can say sometimes it is called as a tower, sometimes you can say the trestle. They are just like your transmission tower you have seen in the your in your high when they are taking a 33,000 kV the electric lines you have seen, transmission lines. The tower you have seen a similar type of tower, or it can be a tower just like you have seen in the your flyovers. In the flyovers you have got a cemented this pillar, similar type of pillar can be there, and on that also you can have that at a distance of 1.5 to 3 kilometers, and there what we will have to see that at that height what will be the wind velocity, will that wind will be swaying and your belt will be going out there, when they will be splitting, that up to what and as because it is a rope it can form a catenary and it can give a sway, and when there is a no relative motion of these two, that means the whole material will be having a sway, there will not be spillage, things will be very good. So, this type of support frames for that whole rope way will be there, and then there will be the belt cover, that is your will have to be provided the belt. Sometimes what happens that you want to protect it from the rain, on that trestle itself you can have a systems to give a cover, that is also possible. The main thing is the belt. The belt will be have to be a specially designed, they have made in such a way it is a flat belt, you are not a troughing belt, because it is not a troughing belt, it is a it has got exactly the stress the strength and other things which will have to be designed is become less, but it has got a corrugated sidewalls, because of that the material will not spill. In an all conveyor belt with the troughing belt, you have seen that when the belt sway go to the side, it hits over there. Sometimes while loading, it is if you are loading at a you are not loading in a properly in the center of the center line is not properly maintained, you have seen the material spill. But here is a flat belt, we have got a cover, you place anywhere the material will get distributed and there will not be spillage. Then there are these cross members, that means your as because these wheels will be connected with the axles, and then we will have to have these cross members at different places to support it, and then also that wheels, that is how we will be having that axle which will be along a cross member, and then on both sides there will be the wheels which are made of your some polyamide wheels and things like that, so that it gives a long life, it does not wear when it is moving over the that is your steel wire ropes, and the friction between the steel wire rope and that polyamide wheel, there should be such a wear resistant polyamide that this will sustain. Now, so that means it is altogether is a different way of transportation, it is a little different from that, it is not like a aerial ropeway. Aerial ropeway we have not discussed, I will be discussing someday about aerial ropeway also. Conveyor belt we have discussed. So, this is though it is using a conveyor belt, but differently. Now, other thing is other than those components, there is the another main component which is used, that is this whole conveyor belt will be carrying material, sometimes it can go even 30 kilometer, that is your one, that is same single belt is taking the material 30 kilometer. So, there if anything is going wrong and all will have to be monitored, and that monitored can be only by measure, that is your monitoring the movement, whether how much it is swing, what speed it is going, when there is a depressions, that whether there is an elongation of the belt, any deviations and all need to be censored. There are many type of sensors, out of this your the Varium Euro sensors, they are making some of this their position censoring equipment, as you can see in that figure, they are fitted at different places, and exactly they acquire all the operational data which will be coming from a place, and this is a 30 kilometer. You do not require any persons to operate or maintain it, only at the end stations, and there are possibility on that trestle you can make a trolley to move along with the people. In between you make a inspection or the survey of the system's health and things like that. So, once we get this system, this is a conveyor system to cover extremely long transport distance, up to 20 kilometer, 30 kilometer it can carry, in which this your whole track rope, they are carried by a suitable number of support towers. For a 20 kilometer length, it may be hardly there could be 12 or 15 towers may be required, and that is exactly this your just like your aerial ropeway. Aerial ropeways are a old proven technology in India also, that is before independence, that whenever there were the private coal mines, they were bringing from the Damodar river the sand for in those days there were many underground mines, but they were having a small tubs of that is your aerial ropeway cars tubs in which the sand was filled from Damodar river and taking into the Jaria coal field. Similar things were there at the West Bokaro colliery of Tata Steel. They were taking the sand from the river side to the mines by aerial ropeway. There were some of these abandoned aerial ropeway you can see when you travel from Jaria to Sindri in near Dhanbad. But this system is having that some of these disadvantages of this aerial ropeway was because the material is taken in a container, it is not a continuously moving. So, the throughput capacity which is much less, but here in this one because it is on a conveyor belt, you can take the 5,000 ton per hour to 10,000 ton per hour also you can carry by this system, and there will not be any spillage. That in a aerial ropeway, that spillage was a biggest problem. So, this is how exactly the RopeCon get developed. So, now there will be the drive stations at the end, one end from there it is driving, and the belt is turned over and that it will go to the other end. Now, you just see here, you have seen in the diagram in the figure, the belt is going like this, and then when it is returned also you are seeing like that, then how it has gone. So, if you take a belt like this, when it will go, that upside will be down. So, that means if you see here in the previously in that figure you have seen that your this conveyor belt, you have seen here that this is both the thing that your conveyor is upside. So, that means when they have gone to the other side, this conveyor belt, after it has gone to the end, they take a turn, and then that means there will be a screwing and then going back, and then the return also is coming in this form. So, one thing is there, you can even in the return side you can bring material to over here. In some places it can be there, say for example, sometimes if you are having a that the locations of your for the transportation of some grain may be there to the this, and then from the mines if you are just taking, think of that in Punjab, sometimes you may think because there in the field that your all the straws haze they are burnt and then they create the air pollution in Delhi. So, if it can be made that is exactly we are having such type of conveyor belt, they will be taking out all the cut materials pulverized and take it to a paper mill or in that near that paper mill, and then if there is a fertilizer or other things, those things can be taken back to the agricultural field. Sometimes that when they take the rice from their main stock to the silo, rice silo can be there in, I do not know whether that in Punjab or Haryana where more rice is produced or the wheat is produced, whether they are big silos. If those silos can be loaded by that from that agricultural field, they can take it over here, and then they may have this return belt taking up those some of the your fine that is the husks. It is husked if it is mixed with certain your other organic fertilizer, you can spray over to the ground, over to the agricultural field. So, that means the rice transportation to the mill, and there is the silo, and from the mill taking out the rice, that is your husk and other waste materials, to put it into the agricultural field, such type of systems can be used. So, those techno-economic feasibility of such systems will have to be studied and developed by you. But here in this figure you can see it is for an aggregate mining, which is there in England and Leicester. They have developed this. This is going to be there in it is just only in last year they were inaugurating such type of systems. So, see that 2007, 6, 7 when this was a technology being talked about, now today it is being applied everywhere. Similarly, when we used to tell about this pipe belt conveyor in the early 80s in Australia and Japan, people were designing it, and in 2006 it has come to India. So, now this is a system which is already getting applied in many places. I hope that in coming 5-10 years some of the installations will be coming if we can make it a more cost effective. So, you can see what are the salient features of this system. This system can take up to 30 kilometer, even more can be designed. It can take 25,000 ton per hour. That is your such a huge capacity. So, that means when we are now having a mine, say Central Coalfield Limited, they are having mines of capacity 40 million ton per year they can produce. Now, that if you are having a super that mega thermal power stations, in a mega thermal power stations, if it is even if it is 20 kilometer 30 kilometer away, it can be connected by this, or in the whole country our thermal power stations, depending on the thermal power stations, we can think of the India bulk material handling of coal, maybe the whole country may be having 100 or 200 big coal depot. Into that depots, from there centrally we may have the number of such type of systems, because they will not disturb the lower ground terrain, will be free for all other activities, the pollutions will not be there, and that it will not use the diesel, and then it can make a total scenario of Indian, that is your your fuel supply agreements of the coal producing country, and the mine and thermal power station linkage can be altogether varying. I hope sometimes that NITI Aayog and all can be taken up, this type of things by some of your engineering and research work can be brought to light by that. So, there are scopes also that it can go inclination up to 60 degree. Even if required, you can give a cleat on the conveyor belt, you can take up to 90 degree also. So, that and it can, the transportation rate is very high. How you are giving 25,000 ton per hour, because it can go up to 8 meter per second, that speed. See, it is normally you will find, and in the thermal power stations and all, for your boiler feeding and all, the way the conveyor belt is being used, it is hardly 2.53 meter per second speed. So, it can go in a very high speed, and in our country most of the places other than the coastal area, wind velocity is not very high, and only during the storm time and all. So, we can make this type of system at a sufficient height also. So, there is a lot of scopes for this technology in our country as well. So, as I said that it operates at an off ground, you can see that how materials are being carried, you can see this. Now, you can see here by the side the trestles, they are having those another ropes on which such type of carriage, which is for the maintenance and servicing, surveillance and servicing. This can be moving over here at a height, this will be just moving, you can travel over here and do it all whatever work you want to do. And this require very less maintenance, because they have got very less moving parts, because there is not many moving parts. So, maintenance is also not required. The top of the support tower is attached to the track ropes, and the bottom is hinged over here. So, that is you can see how both the things are supported like this. Then the top and bottom belts each run on the two track ropes, both the things are having the same type of traction mechanism. Now, that your full locked coil, so that the friction is less, drive tensioning equipment, because these ropes at the end where the driving station is there, you will have to have a very good tensioning of the rope, and for that different type of anchors are there. If you can remember the name Allied Gold is the company who were first developing in Sainsbury. You can see in YouTube some of the very good video of Allied Gold Company of the Papua New Guinea, where they were operating in that was a Papua New Guinean island, Sainsbury Island, in which this type of system. There you can see they very nicely shown how your tensioning arrangement at the end near the drive stations will be there. So, the combination of the technology of cable transportations with simplicity of a conventional conveyor belt is merged here in this technology and has given number of advantages. So, now one thing some of you may be already knowing about, that in India we have got a cable belt conveyor. I think in our introductory classes sometimes I have told you about that cable belt conveyor of Panchpatmali mines at Nalco. If any one of you are there, if you go to that Koraput districts of that Odisha, there Panchpatmali, Damanjari, we have got this National Aluminium Corporations, they have got the cable belt conveyor installed in the 80s. So, that time whatever were introduced, it is still working very effectively, but there this conveyor belt is a different. You can see that there are shoes over there, and this conveyor belt they are having a grip with this wear ropes, and then these wear ropes are moving, that your wheels are fixed at the supporting frame. We are having the wheels, and on the wheels these ropes they are moving on a sheave, and that sheave is driven by motor. So, these are all moving rope. That means the ropes are now having more frictions at the support frames, but in a RopeCon it is different. There the belt is having the wheels and the rope is stationary. As a result, the advantages coming over here, now the whole conveyor belt that is driven by the end pulleys, just like in your conveyor belt you have seen the drive is given by the end pulleys. So, that is the combination of that, exactly two different type of systems. So, sometimes you can find out what is the advantages and disadvantages of these two systems. One is a cable belt conveyor, another is your RopeCon. So, you should study about this, and there are some examples. You can see here, this is in a platinum mines in that is where in South Africa. There is a place called your this Buyzendal. There this platinum mines, they are taking this whole from the hilltop mines, they are taking it to their processing plant at a 4.7 kilometer they are bringing, and they are bringing down up to 530 meter. Similar type of situations are there in India. If you go to in Karnataka, in Hampi side, there are many, that is your in your Hampi side there are a lot of iron ore mines at a hilltop, and from there to carrying to the railway siding systems, that is also sometimes there was 600, 500, 400 to 600 elevation down, where of course we designed some route for pipe belt conveyor, but that because the pipe belt conveyor is still little bit cheaper, because this technology has not come. But sometimes I feel that though we recommended there for the pipe belt conveyor, that RopeCon could be much better. Even as I told you, in 2008 I was giving, because of course we are not a consultant, or we are not given the trust that our academics have got a very limited role in India. So, but we were telling in 2008 that from taking it to the Syria mines of this Syria mines of SAIL, their material to take it, if they take a processing plant at Manoharpur, or from there if they want to even for exporting at a Paradip port, if some from the Borbil area some of the iron ore if it is exported, then taking that will be 120 or like that kilometer, but that also can be taken by such type of conveying systems. I think after that I discussed, some of the officers there, they took it up, and I think with the R&D division of SAIL, they did a study during 2008 to 10. I think that that now retired Mr. Hare Krishna Mahanta of that time, they could be able to give some of you can contact and see that what happened to the SAIL initiative, but this was initiated in India. Now, the conveyor belt has mounted with wheels, as I have said already, that wheels move along the steel ropes. Then the guiding wheels are keeping the conveyor belt from torsion and tilting. That is exactly, we can make the systems in such a way that there will not be any problem for torsions and tilting will not be coming. This system does not require any guiding devices, because it is a flat mounted on this fixed rope, and the systems can work very nicely. You can see over here, when you are doing at a low level, where within that, some of that, when we talk of our the transporting within the mines, from the mines to the railway siding, a very simple system like this will work, and it can be very easily, it can be designed to make in a cost effective way. Only a systematic feasibility, techno-economic feasibility study need to be carried out. Now, this system, it is a combined systems. We can see here that how the your transportations of this, because of the wheel, it is going to give you a lot of advantages. It is exactly much better than any of these railway transport, road transport, and then belt transport. Please make a comparative study of these two. Now, there are a lot of advantages. These advantages, it can carry a very high volume, and that disadvantages is that its maintenance and continuous monitoring will have to be having a special arrangements. So, as an advantage, we can say this is a maintenance friendly system, less moving part. Then it is also, it can have the maintenance only at the stations, end stations you can have the maintenance. It is an environmentally friendly, because it is a very quieter, and also it does not release lot of dust. Then it has got a very high availability, because there are less moving parts, so there will be less failure. So, there is no need of any guiding and all that thing, just like in a conveyor belt you have got a belt sway switch, you will have to have all the time monitoring your sleeves and all, everything is there, is a costly affairs. Now, that is why, because its energy consumption is also less, and the total distance, carrying distance, all you can take the aerial distance only. So, you need not do the terrain clearing, and all this becomes very easy. So, overall the cost is going to be much cheaper, and if you think of a life cycle costing assessment, there is another methodology of study is there. You should do a life cycle analysis of such type of system, and if your mines is having say life more than 15-20 years, this could be a very good economic system we need to study. Then it can be, operations can be automated, and it can have a very good monitoring systems can be there. It can have, because the long span supporting, so total costs on the supporting frames in conveyor belt, there you need to get every meter support, and here only you will be doing a support at 1.5 to 2 kilometer. So, total cost on the supporting in a conveyor belt, the frame, then your rollers, and then the whole monitoring, manpower and all, everything if you take, and then this total cost of having those tower supported things, maybe we need to study, maybe economic. Then line structures guided over towers. So, all things become very convenient for operation, and both the technology, belt conveyor and rope conveyor, they have got already the technology is known, experts are available, only we will have to make their weighting of the rope experts and the conveyor experts, and the ingenuity over here can give a lot of benefits, like longer conveying distance, higher conveying capacity, easy means for the crossing obstacles, rivers and all will not be any problem. You have with this one trestle here, the other trestle here, material will go over. So, it has got a lot of the possibility, even over the township it can go. If you see, there is a one of such type of RopeCon system is there, most probably in Australia, where it is over the towns it has gone, that in to make feeding to a thermal power stations. I will have to confirm and verify that, but it is there, you can search in a Google Maps also, you can see over there. Then no maintenance parts along the track, then significantly low kinetic resistances with the conventional conveyor belts, then minimal noise emissions, that no belt skewing is possible, belt will not get turned and shifted, and that is your belt, that training problem does not come in conveyor belt. You will have to do all the time training, that means your alignment need to be checked, here those things are not there. So, there are a lot of advantages are there, and the main elements, as I said, it has got some movable element and some immovable elements. Movable elements are mainly your that belt and the drive and all will have to be done over there. So, this is a system which has got only the conveyor belt will have to be a special type, we will have to design. In India, we do not have a proper belt manufacturer, but maybe if that political will is there and then the Coal India Limited join with the Dunlop or other rubber belt manufacturing company, this manufacturing can be taken up with the that is your with make up that is make in India move, and the amount of experts available in our country on the rubber technology with the belt technology, we should go for here. As I told earlier, we do not have that manufacturing of the large diameter tire, because that if our this system is also taken move, then to manufacture those type of conveyor belt and then manufacturing large diameter tire in India, some of those manufacturing company can have, but provided the mining industry take the decision that this is the amount of the business which will be coming, the if the a macro planning of our economic planning is done, such type of industry may be viable. Then supplementary component of is the sensors movement. Those are the things that sensors are for monitoring the conveyor health. Here, as a bulk material handling and transportation engineer, you will have to find out with the electronics and instrumentation departments, with the other your friends, then develop your peer review that what type of sensors can be there, and then only when you know the technology, you will be knowing that how different data will have to be collected and how it could be modeled and over there. Otherwise, those hypes of people telling about that artificial intelligence, machine learning and all will be just your wastage of some of the technical manpower into that is a non-technical operation. So, please go through this, try to develop a small model and see here, discuss with your electrical counterpart that how the drive system will be given. The drive of a this RopeCon, whether you will be doing it with a directly with a AC motor, that speed control and all will have to be done with a digitally, so that that is your all the advantages of DC motor can be brought with the AC motor by properly converter and inverter systems over here. So, there is this part also is a study which can be initiated. The most important thing is how we will be having the brakes and the controlling of the total drive systems of this conveyor belt will be there. Now, there are examples, there are many places these are there. I have given you this list, check over here, so that if you take out some numericals, that if you create some problem and try to solve, how near you go to the whatever is been established there, you can verify whether you are doing in the right track or not. So, you take up any problem, say you want to transport material from say Kiriburu mines or Megataburu mines to their processing plant, by that collect the real life data, and for that you do the calculation and see how near you are there with their the design and your design. So, that type of, so you should do certain case studies like that. Then another most important thing is there that in our underground mine capacity cannot be enhanced, because the from the underground mines evacuation depends on the winder, and in the winder we have got shaft diameter is fixed, and that is why we have got the cage and skip that they have got to very limited capacity. So, even if you are using a very high productive machinery, shearer or continuous miner in the underground mine, from there the material to be taken up with the shaft will not be possible. Now, if there is a conveyor belt, of course, that will be bringing over there, but then also the material transport and then maintaining a that your pit top layout for getting this whole material to take it to the washery, there is some issue. But if we think of that one of the that is your upcast or downcast shaft, if it can be provided with such type of systems, that is from the face this whole thing will be going, and then during the vertical period it will go vertically, or we can have a that is your inclined shaft can be made through that this material with a where it will be coming. After coming over there, it can go to the trestles and take wherever you want, 20 kilometer, 30 kilometer, no problem. So, many of the your even it can be that in a naval lignite type of mines, where that mine pit head and then the thermal power station is not far, then of course, they are already they have got the conveyor belt, but in their future mines and all, if they go from there instead of the conveyor belt, sometimes this can be thought of, which can give a much more advantages. So, there are various applications are there. Please chart that in Guatemala they have been using it for limestone transportations. You can see the terrain and all that thing, that in India or in any country where there will be truck haulage for taking up that, the forest will never remain like this, but with that system which is put over here, no dust is going to get the your stomata or that the lower that leaves hole will never get obstructed, the health of the trees will never get damaged in this type of area. So, that is why when we talk about that environmentally friendly mining, we need to, we just do not believe in just taking an environmental study and measuring the air pollution and telling that this is the report, that is the thing. If you want to do environmentally friendly mining with the transportations, you will have to bring technology. So, I request that do not get allured by studying the air pollutions and all, but we need to do the, for avoiding the air pollution, we will have to incorporate technology and see their feasibility and applicability. So, this is again I have shown you already this our platinum mines. So, there are a lot of references are there, please go through it, and RopeCon can be an option of transportation for the future deep and large surface mines. Directly from the underground, it can carry to load the silos in the rapid loading system of Indian Railway, and then there are more R&D and techno-economic feasibility study is required. Maybe towards the end of the course, I may be introducing you how to do this your techno-economic feasibility study, because unless and until our technical learning is embedded with the techno-economic studies and feasibility, this learning and knowing has got no use. So, my dear friends, I hope you have understood now what is RopeCon, and please develop your own learning activity. Thank you.